हॅलो एव्हरीवन, वेलकम बॅक टू एम्बेड सिस्टीम कोर्स. तर आज आपण आतापर्यंतचे जे काय आपण 4 प्रॅक्टिकल्स केलेले आहेत, तर त्यामध्ये आपण सिम्युलेटरवर आपण आउटपुट चेक केलं होतं. तर आपल्या लॅबोरेटरीमध्ये 8051 साठीचं किट उपलब्ध आहे, ज्यावर आपण जे काय प्रोग्राम्स आतापर्यंत केलेले आहेत तर त्याचं टेस्टिंग करू शकतो. ओके, तर त्यासाठी आपण ज्यावेळी किल कंपायलर मध्ये प्रोग्राम बिल्ड करतो तर त्यावेळी त्याची ऑटोमॅटिकली हेक्स फाईल क्रिएट होते. तर ती हेक्स फाईल आपल्याला या किटवर जो काही मायक्रो कंट्रोलर आहे, तर या किट मध्ये 8051 कंपॅटेबल मायक्रो कंट्रोलर आहे, 89S52. ओके, सो दिस इज द 89S52 मायक्रो कंट्रोलर. आणि आपल्याला या किटवर pins are taken out for the connection. So these pins are for port 0, that is P0.02, P0.7. Okay, these pins are of port 2, that is a P202, P27. These pins are of port 3, P302, P37. These pins are of port 1. Okay, so P102, P17. Okay, this is matrix keyboard, 4x4 matrix keyboard that can be interfaced with port pins. Okay, so these are LEDs. We can see output of any port pin on this LED. Okay, so these are LEDs. Then this is ADC chip. So this is a ADC 0809. For interfacing of this ADC with microcontroller, pins are taken out. Okay, so this is LCD which can be interfaced, okay, via these pins. So these are data pins of LCD, and these 3 pins are RS, that is register select, RW, and enable. Okay, similarly here we can also interface 7 segment display, okay, for which pins are taken out here. We can interface these pins with port pins of 8051. Okay, depending on your requirement. Okay, you can also operate this 7 segment LED display. Okay, so this is buzzer. So we can connect port pin here. Okay, and we can, if it is 1, it will sound this buzzer. If this is 0, it will turn off the buzzer. Okay, so this is onboard battery. Okay, so these are major IOs. Okay, similarly here you can see this is a switch package, 8 switch package. Okay, so if you push this switch towards right, it will turn on, and if you push towards left, it will turn off. Okay, so you can make connection with these switches, okay, of port pins of 8051, okay, via these pins taken out. Okay, so these are the peripherals that are available with which you can interface this onboard 8051. Okay, and according to your program, okay, after that you can make interfacing of 8051 IO ports with the peripherals. Okay, and then you can write, okay, or you can flash your program's hex file into this 8051's program ROM. Okay, so for that you have to interface this kit with your laptop or desktop. Okay, for that here is serial interface. Okay, so that serial interface is converted to USB interface by using this converter. Okay, and finally it is connected to the USB port. So this is a USB pin. Okay, so that can be inserted into one of the USB port of your laptop or desktop. Okay, so right now So right now I have a program from practical number 3. Okay, so this is the program. So this program, it is turning on bit number 4 of port 2. Okay, P2 caret 4. Okay, that is my bit. P2 caret 4. That is address of pin number 4 of port 2 is assigned to S bit type of variable, that is my bit. Okay, and a program is written which will continuously turn on and off this bit, that is pin number 4 of port 2, continuously or infinitely with a delay of 250 millisecond. Okay, so MS delay is called after resetting this bit. MS delay is called of 250 millisecond, and after setting again same delay is called, and this is a MS delay subroutine. Okay, now here to generate a hex file of this program, you have to click on this build button. Okay, so if no errors found, that hex file will get created. Okay, but for that you have to, in a project menu, in options for target 1, okay, in this open window output, and here you have to check this box, that is create hex file. Upon build, then hex file will get created. Okay, so here where this hex file will get created, so that hex file will get created in a project folder. Okay, so see here, so this is the project folder of a project practical number 3, and these are the program files of practical number 3. So this is prog2.c file. Okay, and this is the project file. So in this folder, that is practical 3 folder, where prj3 project file is saved. Okay, so inside this there is one folder having name objects, and inside this object that hex file will get created having name same, that is project name. Okay, so project name is prj3, so the hex file will get created having same name. Okay, that is prj3.hex upon build. Okay, so this program is build. Here we have build. Okay, after that what will happen, its hex file will get created in this object folder, Okay, so this is the object folder. In this object folder, so this is the prj3.hex. This you have to write. Okay, now we have hex file and we have this kit. Okay, now our objective is to write this hex file into program ROM of this 89S52 8051 compatible microcontroller. Okay, for that we have interfaced this kit with our laptop on which necessary softwares are installed. Okay, so you have to install that USB driver software, okay, for this kit, and as well as you have to install Explore Flash software. Okay, so AVR viewed Explore Flash software you have to install. Okay, so if I open it to write that hex file, I have to open this software. Okay, here I have to select. Okay, once that Explore Flash is open, you will have to select a programmer. Okay, so here you have to select USB ASP programmer. So here this is the option, USB ASP you have to select. Then you have to select microcontroller. Okay, so on this kit. Okay, so So 89S52 microcontroller is there. It is not legible here. Okay. But 89S52 microcontroller is there. So I have to select this. Okay. After that, I have to browse the file I want to write. Okay. So here for that, I have to click on this button. Okay. So port I can select, that is USB port. Okay. So other things not necessary to select. So here I will click on browse. Okay, then I will open this practical 3 folder, and from that folder I will open objects file, objects folder. Inside this object folder there is a hex file, that is prj3.hex. HEX, HEX. Okay, so prj3.hex. So that file I will select and I will click on OK. Okay, so OK or open. Okay, and then I will click on program. Okay, so that is written. Now see here. So this program, if you see, this program is generating or it is toggling pin number 4. Okay, so pin number 4 of port 2. Pin number 4 of port 2. So uh, so first I am making that pin 0, then calling 250 millisecond delay, then I am making it 1 and calling same delay, and this is continuously happen. Okay, so now see here, now that program is written and it is giving us output because I have, so this is the port number 2 and it's pin number 4. Okay, so this is the pin number 4, okay, of port 2 that I have connected to buzzer. Okay, so buzzer is making sound because we are toggling this pin number 4 of port 2 continuously after 250 microsecond. Okay, same output I can see on LED. So here I can connect to any LED, so that LED will be on for 250 millisecond and that will be off for 250 milliseconds. Okay, so continuously that pin number 4 of port 2 is toggling with a delay of 250 millisecond. So I am making output, I am getting output like this. Okay, so continuously that LED is turning on and off with a delay of 250 millisecond in between. Okay, so in this way, each and every program you have studied, okay, up till now, you can test that program on this kit. Okay, for that you have to interface these kits. Okay, USB cable. Okay, so USB converter is here, so that is interfaced with USB port of your laptop. On laptop, you have to install the driver software of this USB. Okay, that is USB ASP, that is called as USB ASP, and you have to install the Explore Flash. Okay, Explore Flash software. So through this Explore Flash software, you can write, okay, the selected hex file, okay, into the program ROM of this 8051 compatible, that is 89S52 microcontroller on this kit. Okay, and you can check the output. Once that program is successfully written, you will get output. Okay, or if you are not getting that output, even if after writing program you have to wait for some time, or you have to press on this reset button. Okay, so upon reset again you can check the output. Okay, so okay, so there it is. So there might be problem with LEDs.